So, good afternoon, everyone. Hi. As Ben just said, I'm your warm-up act. Hi. I'm Alyssa Goodman. I'm one of the co-directors at Radcliffe Institute for Science. I'm also a professor in the astronomy department and on the steering committee of the data science initiative here at Harvard. And those organizations, not counting the astronomy department, are bringing you, along with the Institute for Advanced Computational Science, 2 talks by Ben Shneiderman here at Harvard today and tomorrow. So you're at the first one. Hopefully you're at the right talk. And tomorrow you're welcome to join for the second one, which I think is in the geological classroom. The information is right up there, as well as the topic. But what I'm going to do is first, I'm just curious, before I tell you anything about Ben, Ben and I are both curious who's here. So if you are considering yourself a computer scientist or that your first field or interest is computer science, can you raise your hand? Thank you. If you're from industry, can you raise your hand? A few people? Thank you. If you're from Harvard, can you raise your hand? Okay, if you're from not Harvard, can you raise your hand? Okay, Ben, you want to know their favorite color? What else you want to know? If you're very interested in design, raise your hand. Okay, excellent. And what about the humanities? Any actual humanists? Wonderful. Okay. Library people. There we go. Thank you, James. I know his name. So he'd like social scientist next. Okay, wait. Why are you so hesitant to raise your hand if you're a social scientist? It's like, ooh, it's our fault if this AI stuff goes wrong. Anyway, so let me just tell you a little bit about Ben, unless we really do need to know their favorite color. No, Ben? Okay. So, so you probably, most of you have heard of Ben or Ben's work, and you should be very grateful to him every time you use your iPhone or tag someone in a photo. And maybe he'll explain some of his work today in the more design usability aspects of the interaction between humans and computers, which is what Ben has been interested in pretty much for most of his career. He actually started out, right now he's a distinguished university professor at the University of Maryland, and he started something there, the human-computer interaction lab there at the University of Maryland, something like 40 some odd years ago, but 35 years ago. But before that, he actually was trained originally as an undergraduate in physics. I love the fact that he also went to Bronx Science, because I'm originally from New York too. So for anybody here, I should have said, who here went to Bronx Science? Anybody? Oh, come on. There's usually at least one. Okay. But he did go to City College, where my dad also went. Okay, we got a City College person. Excellent. Okay, so he went to City College, and then he went to Stony Brook after getting his bachelor's in physics at City College. He got a PhD in computer science. And then he says he sort of became 20% a psychologist because he became more interested in not just what computers could do, but what humans and computers do together, where humans use computers as tools. Right. Don't say that humans and computers are partners when you're with Ben. This is just a bad idea. If you try it in the questions, you'll see why. Okay, so anyway, so Ben has done many, many things in his career that led to important technologies that you use in your everyday life, including hypertext, touchscreen computing, tree maps, and other kinds of visualization, the names of which you might not know, but Ben and his colleagues are responsible for them, making your lives navigating lots of information through computers much easier. Tomorrow he's going to talk about event flow, which is one of the technologies he's worked on more recently. And some of you may know about Node XL, which is a graph visualization tool. But today he's not going to talk about any of that, I don't think, or a little bit. And so I'm just going to say one more thing, which is Ben has these rules about human-computer interaction, usually applied to visualization, information visualization. And I just picked out one that I want to read to you so that you can keep it in mind as you hear Ben speak. And you'll see the connection between design and human-computer interaction design and his thoughts about artificial intelligence and machine learning. And so rule number 7 from his famous book, Designing the User Interface, which first came out in 1986 and is in its 6th edition now, says support internal locus of control And then that's explained as experienced operators strongly desire the sense that they are in charge of the system and that the system responds to their actions. Design the system to make users the initiators of actions rather than the responders. Okay, so I think we'll learn today what that means in the context of artificial intelligence, and we'll also learn why an important quote from Ben is that machine learning without visualization should be illegal. So we'll find out what that means, and thank you very much for coming, Ben.
Thank you. Thank you. Oops. Thank you for that nice introduction, and you gave half my talk, so we can move it along. I'm very pleased to be here. And once we get my slides, we will be, that's not what we want. Yeah, you want to try that again?
Oh, you got it.
All right, I'll try it that way. Okay, no slide viewer, straight up slides. Good afternoon. I'm very pleased to be here. I've had an energizing day talking with students and Radcliffe fellows, visiting around the campus, and I'm ready now for a spirited discussion with you here today. Alyssa's already said I'm happy to be from the University of Maryland and represent the 35-year-old Human-Computer Interaction Lab, an interdisciplinary bunch between computer science and the College of Information Studies, rapidly growing and known as the iSchool, but also we work with other groups on campus, including the wonderfully titled Maryland Institute for Technology and the Humanities, MITH. There are about 1,000 tech reports on our website, 200 videos, 200 project reports, and so on, so you can take a look about that group. Alyssa's already mentioned the book, Designing the User Interface. That's been my calling card. I hope some of you have seen it or used it, and it covers some of the key things in direct manipulation theories and the way to design screens and menus and search systems, social media visualization. And Alyssa was kind enough to mention the 8 golden rules. I was pressured to, reduce the 500 rules that were in these large books and handbooks, and it was useful because it forced me to think at a little higher level. And so there were things like strive for consistency and prevent errors. And the one you said, which was from an earlier version of that book, which was asserting internal locus of control. I sort of updated it in the latest version to just simply, the locus of control phrase confused people, and so I just focused about assuring the users in control, and you'll see that's going to come back in the story as well. Just where I come from, as Alyssa described, from a background doing database and file design optimizations and working my way towards psychology. In 1980, I wrote the book called Software Psychology, and tried to bring these disciplines closer together. And along the way, some design things travel really well. The idea of links, that certain words are highlighted in a sentence, and we chose light blue because we studied a dozen versions and we had all kinds of research, and bright red was more visible, but it undermined people's comprehension and retention of the text they were reading. So blue turned out to be good. Tim Berners-Lee said, oh yeah, that looks good, and he cited our work in his manifesto for the web in spring '89. So those things traveled really well. The touchscreen keyboard, early on, we had done a 9-inch wide keyboard with inch square buttons, and we did 7 and 5 and 3. And we studied them, and yes, it does take a little longer on a 3-inch wide keyboard, but people could do it. Now, the reviewers of the paper didn't believe it. And it took a video to convince them that it was really possible. And the strategy was to put your finger on the screen, give a little cursor just above your finger, and then be able to move it around, and that's still what resides on your iPhone. We called that the liftoff strategy, and Steve Jobs, I was a consultant for Apple, and Steve Jobs visited our lab, so there again I see the path for those things to happen. And things like photo tagging we did, and we got a patent for that, and that's traveled well also. So those are easy stories to tell at cocktail parties. Some of the more difficult things, which I'm proud of as well, a Spotfire tool that came from our work, which had the early ideas of multiple windows, dynamic query sliders to control ranges, rapid, incremental and reversible updates, brushing and linking. A lot of those ideas came from the early developments there. There's tree maps in a financial tool, FinViz, commercial one, where it shows 500, all the stocks in the S&P 500. The green stocks are rising, the red stocks are falling. The area indicates the market capitalization. And so you can see Apple is the biggest one, and there's Google and Facebook and ExxonMobil and whatever, all these other different groups. And it's a pretty good day in this example here. But there are some red ones, and you can see as a field, the utilities sector is doing poorly, and often that sector travels in the opposite direction of the general stock market. Node Excel was a network visualization tool, 600,000 downloads, and we're working on the second edition of that book. And this was the first visualization of the polarization in Congress. These were the red Republicans. I've lost my cursor, come on. Can you see that? Yes, you can see it. I'll try this way. The red Republicans and the blue Democrats, the two independents, Sanders and Lieberman. This is about 2004. And then the three crossovers are Specter, Collins, and Snow. And that proved to be predictive, if you will. That's a word near and dear to Alyssa, but predictive of the three Republicans who would vote for Obama's Reconstruction rebuilding plan. So that's the kind of data sets we were after. It's still available in a free version, but also a paid version. And currently, event flow, and that's tomorrow's talk, is about for looking at electronic health records. If you have 1 million patients and you want to look at the common patterns of treatments and outcomes, this is the way we hope you'll do it. So take a look. And Megan Monroe is one of the key workers on developing event flow into the powerful tool that it is. Take a look at her videos on the event flow website. My favorite one is the one about her analysis of a basketball game, of every shot and pass turnover, and she captures in a charming and brilliant way how the game turned out in a way that was not visible from other statistics. So this talk is about big data, okay? And big data is often described as a flood, as a torrent, as a tidal wave that's drowning in data. All these negative views of the way data is overwhelming us. For me, though, data is really good. It's the sweet irrigation from which we will forge the new ideas that we need to make our world still better. So I'm here to change the metaphors and to push us down a positive road that says big data is great opportunity. And now we have to figure out how to put it to work, how to put it to work responsibly and safely. And those are going to be the key themes. So I go back to the original big data initiative that Obama launched. It's now 2012, so 6 years ago. And in this 3-page White House announcement, there were 2 challenges. Developing scalable algorithms for processing imperfect data and distributed data stores. Quite nice. That's the machine learning and algorithmic approach and doing all those things. However, number 2, or equally, the other challenge, creating effective human-computer interaction tools. Pretty good. I had some influence on this document, so my words get in there too. For facilitating rapidly customizable, and I like this phrase, this was not mine, but visual reasoning for diverse missions. So I want to remind you that while we may be talking about technology solutions here, we also have to, at the same time, talk about human solutions. That's where we're going. The White House repeated the big data strategies a couple of years ago. There's too much to read here, but I want to focus on one piece of this. Support R&D trustworthiness of data and the resulting decisions, okay? And they use this phrasing, which I liked, promote transparency, including tools, they got it again, that provide detailed audits, I like that, to show the steps that led to a specific action. Okay? It's pretty clear and straightforward about what the White House was asking for in terms of building the right kinds of technology. Now, I had addressed this issue, and again, thanks to Alyssa for mentioning the book, originally in 1986, and there was a section which was titled Balancing Automation and Human Control. And it was built on Tom Sheridan, MIT researcher who had cataloged 10 levels of the movement from human control to full automation that had machine control. And that vision has remained the stable part. It's changed in some ways. In fact, in the driverless car world, there are 5 levels of automation now, and so there's that way of thinking continues to dominate. However, I began to diverge from that, and I just didn't like the idea of partnership, of working together, or of balance. So in the 6th edition, that section, you can read that and get the full story. It says, ensuring human control while increasing automation. And that may sound like a bit of a mystery, like a koan of some kind that you need to meditate on, but that's where I've come to stand quite strongly. That I think we're going to want to be clearer and clearer that the humans are in control, and therefore the word responsibility will come into play. And the way we get it is by getting increased but the right kinds of automation. Okay, so that's where we're going to go. Now, these ideas have some merit, and I just want to remind you that the notions of user control, and thank you for mentioning that was originally in my list, but Apple and the Microsoft guidelines still say the same thing, that they stipulate, this is Apple design for their products and the iOS apps, people, not apps, are in control. Okay? Flexibility, whoops, come back here. Flexibility, users complete fine-grained, flexibility, the users complete fine-grained control over their work. Okay, that's also a pretty clear statement. So this is quite at odds what you see in much of the literature and descriptions about AI, machine learnings, and machines are taking our jobs, and the rise of the robots in a variety of other ways. And so that's where I want to take you here. I hope to convince you by the end that this is a fresh and important way to think, and we need to change the language of discussion and the way we go about building new technologies if we want to build safety. That's really our goal. Again, there's other people, other voices that I join with. Cathy O'Neill's excellent book, Weapons of Math Destruction, describes the dangers of opacity, of black boxes, of when algorithms are used at scale and they produce damage. These algorithms slam doors in the face of millions of people, often for the flimsiest of reasons, and offer no appeal. And she has chapter after chapter that talks about how teachers were fired, how loan applicants were rejected, how prisoners requesting parole were rejected from that, and on, medical applications and so on. So she has written this in she's a Harvard grad, by the way, and worked on Wall Street, and PhD mathematician, but she's written a wonderfully compelling book that makes the case. And her point is that algorithms can be biased, harmful, and deadly. Okay, I guess this has become common knowledge. I hope everyone in the room has seen these arguments and appreciate that there is tension. In preparing for this talk, I went out and captured the covers from recent reports. My favorite, if you're going to read one, is this one, Ethically Aligned Design. This one I really like. It's about 200 authors from 20 committees within IEEE. It presents fresh language, fresh thinking, practical ways forward. That's the one I love. I wrote a blog for IEEE, a sort of love letter for them. The bad guys are over here. That this report, which is a little older now, does suggest there's nothing different between people and machines. It's just a degree of, the speed of performance. Human minds and computers are quite the same. So I didn't quite like that one. This is an interesting one that focuses on malicious use of AI in forecasting, prevention, and mitigation from people that we all respect, like the Electronic Frontier Foundation, Cambridge and Oxford Universities, so on, OpenAI Group. And this one from the World Wide Web Foundation on Algorithmic Accountability, a nicely written report that focuses on the web. And there's more. This is a recent one, European Group on Ethics in Science and New Technologies, Artificial Intelligence, Robotics, and Autonomous Systems. And this also, just a couple of weeks ago, Upturns, a Washington-based think tank and supported by the Omidyar Network, and then the New York-based AI Now, NYU, Kate Crawford and Meredith Whitaker are key players in here. But they follow ideas that are close to what I'm saying, and so that's one I'm sympathetic to, and it's just recently released. Practical Framework for Public Agency Accountability. So this is a topic that's in the air, and I enjoyed the discussion with the Radcliffe Fellows this afternoon, and I hope many of you are aware of these issues. My pitch is responsibility is the key to understanding it, particularly responsibility for failures. So that's the model I'm going to build on, and there's going to be two other components to it as well. Now, an important player for this report, don't read all this, but is the two-page report from the USACM, which I'm a member, and I was part of this committee, which is the public policy group of the Association for Computing Machinery, the main professional group with 100,000 members. And they got together and prepared this report, which was then endorsed by the European branch as well, and it has 7 principles, and we're going to look at those. Okay? And I would say this is a good one. It's good to read. It's just a page and a half, so it's a very readable thing, and it has 7 principles. My criticism, and in the short time we had to push this report forward, I couldn't get the specificity that I wanted, but they're on the right track. So, awareness. Owners, designers, builders, and users of stakeholders should be aware of the possible biases and harms. There actually should be a 0th level rule, which is the awareness that there is a system, an AI system being used in some of these environments. In fact, Nick Diakopoulos has begun to collect as a website, which he lists all government, as much as he can find, government systems which have AI systems built into them, which have potentials for bias. So, we should be aware that things are being done, and then we should be aware of the possible biases and harms. But I was critical of shoulds. When you see shoulds in a statement, should be aware. How do you know if someone's aware? And who should be aware? Who certifies this? How do you validate that? Similarly, access and redress. Regulators should adopt mechanisms that enable questioning and redress. Which regulators? How do you get a question asked? What's the redress? What's going on here? Okay? A good principle, but it's a bit high level, and we need to make it more specific. Accountability. Institutions should be responsible, even if it is not feasible to explain how algorithms produce the result. So who holds them responsible? And we're well past the time, and this proposal is a year old, and I think the movement has gone well past, everybody says, yes, this is right, but now how do we do it? And so that's really the substantive discussion that I hope to contribute to. 4th, explanation. Another hot topic. Systems and institutions that use algorithmic decision making are encouraged. Oh, sure they're encouraged to produce explanations of the procedures and decisions. How do they do that? And when do they do that? And where do they publish that? And who can see it? So I think there's a lot that needs to be resolved here. There are industry committees or government agencies around the world that are pushing towards this happening. Explanation is a particularly key issue. In Europe, the GDPR, General Data Protection Board, will start on May 25th, will require that companies give explanations to people who feel they've been harmed. Now, it was well-intentioned. It's a good idea. I support the GDPR. However, it was pretty vague about how that's going to happen. So the appearance of that will change things in Europe, and I hope eventually move to this country. 5th, data provenance. Algorithm builders should maintain a description of how training data was collected. Where do they keep this information? Who gets to see it? Is it open? We don't quite know. What's the format of this information? Okay, we don't yet know. Again, I repeat, I'm happy with this report, but there's still work to be done on any one of these. If you're working in these areas, you contribute to any one of these 7, you'll be doing something valuable. Auditability. Models, algorithms, data, and decisions should be recorded so they can be audited. I think you know what I'm going to say. I mean, what do we mean by should? Where do they get recorded? What form do they get recorded in? Is there a standard way? Is it a machine-readable form? And what if we don't like the way the audit report has been prepared? So those are the questions. Validation and testing. Institutions should use rigorous methods to validate their model. Which rigorous methods? How is rigorous enough? Okay? And I will tell you that while there are those who say we don't want to have any regulations that will limit innovation, it's sort of a current mantra of many people, the fact is many of the people in the companies I speak to actually want a clear message. They want to know, what should I be doing as a responsible company in order to do the right thing? How far do I have to go? What will make me be seen as a responsible corporation, and that when things go bad, the public and the insurance companies will say, you did okay, and will not fault them for being insufficient. So I think the insurance companies will be our friends in this domain, as they have been in many other areas, like the structure of buildings and housing. That's certain, they'll provide insurance if you have flood protection, if you've used the right kind of construction materials, and so on. Okay, so I come back and just remind you the sort of mantra I want to wash over you, because changing minds is hard. I just want you to remember, we want to ensure human control while increasing automation. Okay. And my mechanism for going about doing this is a well-practiced method, which we will have to adopt to the new situation, and it's independent oversight. I became involved and studied 40 different systems of independent oversight and developed a little taxonomy, which is what I want to get to here, and see how then we can apply this in the case of algorithm design. So there are independent oversight mechanisms. Every company that registers with the Securities and Exchange Commission must have an internal audit committee and advisory boards and external audits. And we kind of accept that. There's more than 10,000 companies which go through this process every year and file their reports with the Securities and Exchange Commission. And there are rules about how these external audits get done. The big accounting companies make a good amount of money on this, but hopefully they provide value because they give the kind of stamp of approval that says you're doing the right thing. And that makes it better hopefully for all of us. Now, there are certain rules that have been practiced over the year that says, look, the external auditor has the right to see this and this data and not to see that data. There's also criteria about what happens to the report of the external auditor. It's not very useful if you have an external auditor who writes a report and nothing happens. So there's an expectation that within a year, these companies will follow up on the recommendations of that report, so that when next year's report is done, there can be some feedback and validation that this is going okay. All right. University accreditation, NSF, and British EPSRC advisory boards are all other forms of independent oversight. And of course, tenure committees are another form of oversight. And the right level of independence in each of these is important. For committees, there should be people who know the discipline well enough, but not so close that they're completely submerged in it, or not so close. Same thing when the Federal Reserve has oversight of banks. They want people who know the banking industry and maybe know the company fairly well, but not so close that they're friends with the people who are the leaders of the company. There's rules about subpoena power and investigation, reporting, and what can be made public. So these are all well exercised, including many of these other technologically centered organizations like NASA, the FAA, Food and Drug Administration, Department of Home. All of them have some forms of independent oversight, and these committees evolve the strategies for doing their investigations. So the National Transportation Safety Boards may be the most, I think, respected and effective of these, and we all know about them. And I'm talking about a National Algorithms Safety Board. Okay? So The Transportation Safety Board did come in for the Tesla car crash a year ago, which killed the driver. And if you read their 60-page report, it's quite nicely done. I was quite impressed, actually. And it describes all the circumstances and then has a set of conclusions and then recommendations. Now, among their recommendations was one that's near and dear to my heart, which was careful logging of what happens. And it turns out that Tesla did not have the kind of logs that would enable the outside investigators to understand what's going on. Okay? Now, the model again is the flight safety recorder, flight data recorder on airplanes. When a 777 crosses the Atlantic, there's about a petabyte of data generated. And that's a huge amount of data. But there's been an industry agreement about how to structure that data, and there are software tools that let the analysts understand what's going on. And I think the development of those two strategies will be one of the things we want to see for AI robotic systems of the future. That we need to have a careful logging that's been decided on. Maybe it's different for medical devices, maybe it's different for aircraft, maybe it's different for financial transactions, maybe it's different for business decision-making systems. And there'll be increasing levels of care when we move from discretionary systems, lightweight things like recommenders, to consequential things like mortgage financing, hiring of teachers, parole, and so on, and then, or financial trading, and then things that are life-critical applications like transportation, medical devices, and so on. So we're going to need to get more nuanced in understanding what to capture in each of these cases. And while the NTSB did fine, I think, because of their experience with the Tesla crash and the recent Uber pedestrian death, they're still investigating that one, of course. I think broadening it out to an algorithm safety board would get a cadre of investigators who come to know what to look for when disaster occurs. Now, so I'm proposing 3 kinds of oversight, and the first one is planning oversight. That's in advance. If you're going to launch a robotic or AI system, then like a zoning board, where you come forward, you say, I want to build a house, and here's my plan for building this house or this store or office building, and the zoning board reviews this and then gives you approval to go build it. And then when you're done, the zoning inspector comes back, checks out that you did it, and gives you a certificate of occupancy. And over time, that process of discussion in advance leads to a wise set of guidelines about fire rules, that you can't use asbestos, that you have to use certain kind of construction materials. You need structurally strong, depending if you need a 2-story or a 12-story building. And all those things become open discussions where everybody knows what the code is, and what the code will be for these robotic systems will emerge, again, I think, industry specific. And I think that's a nice kind of adversarial approach where people discuss, someone says, I want to build this building, and someone may say, well, you know, we're your neighbors, and we don't think you should build this building because it's going to cause subsidence or floods or so on. It's going to block the light of our building. Or others who say, we're speaking for the fire department, and we just can't feel that we can have our firefighters go into this building because it's not built according to the strength and safety we want. Or these days, earthquake resistance, flood resistance are other issues. And we'll come to understand where the dangers are in different biases of machine learning systems. Second approach, and this is the more expensive one, so I'm sort of less pushing on this one, but this is the Federal Reserve Board, and they do continuous monitoring, as does the Food and Drug Administration for pharmaceuticals and meat packing and food packing and distribution and other circuits. These require someone to be there and watch what's going on and ask the right questions and keep it going. Okay? So continuous monitoring is expensive. And, it results in things like the Federal Reserve coming, one day and saying, it looks like you denied loans to 27 black women yesterday. What's going on? And is there a reason for it? And then the bank says, we had no idea about that. Why did that happen? Let's go check it out. We don't want to do that. And so the monitors and can be an asset for the companies as well. Doesn't always work as wonderfully, and sometimes things go bad even with monitors, but the evidence is very strong that this kind of continuous monitoring is very effective. Again, very expensive, but very effective. The third is, and probably the clearest case, is the retrospective analysis idea. When something bad goes on, when a Tesla car kills somebody or Uber runs over a pedestrian, somebody shows up who knows how to investigate and has access to the data. And this, again, has to be independent. It can't be that Tesla or Uber say, we'll check it out, we'll do our own study. No. I'm advocating the idea that independent oversight has value, and you want to create a certain tension, and you want to develop the strategies by which the analysts can come in, and where the company says, no, you can't have that part of that's our protected company information, but you can't have this information. That's what we've all agreed to. So here's my little model of it, and this really gets me to most of what I want to accomplish here. The idea that there are social strategies that can produce the kind of technical solutions. Now, the technical solutions I've suggested already. The first thing I want is appropriate monitoring and logging of what happens. Okay? The second thing I want is a proper modular design of algorithms so that analysts can understand what's going on. I would say the model for this is debugging tools, where you don't just print out everything, but you have certain breakpoints in the program's modularly designed so that you can track where the problem is, and you can say with authority, we fixed it. That problem won't happen again. Okay? And that's how I think airline systems have become such safe and good models of what we want to build for manufacturing robotic systems. Apparently there are 33 deaths by robot manufacturing systems in the US, and from what I understand, only 2 of them are fully understood as to what went wrong. And that seems frightening to me. So I'm here to raise awareness and promote an approach which will provide the social, political, or maybe legal mechanisms that will drive the right technical solutions. Okay? And these issues about degree of independence, subpoena power I've mentioned, and the power to enforce recommendations. Now, you can get my short paper about this in the Proceedings of the National Academy of Sciences, from which this figure is taken. So I come back one more time here to say ensuring human control while increasing the level of automation. And just to, we have many ways in which we have highly automated systems, but we feel in control. When you step into an elevator and you press 7, the light goes on that says you're going to the 7th floor, and you see you're on the 3rd floor now, and you get to the 7th floor. And the systems are comprehensible at the level you want. They're predictable, that you press 7, you get to the 7th floor, and they're comprehensible, predictable, and controllable. Okay, you can get where you want to get. Now, they're not completely in control, because there are limitations of what you can do. But within the cognitive model of the users of an elevator, they have a sense of comprehensible, predictable, and controllable. And those, sometimes you've seen new elevators which don't quite have all these features. There are ones that don't display the floor you're on or you're going to. They're kind of scary, and you feel out of control. And I would say this is the phenomena that happens with airplanes which have excessive degrees of automation in the autopilot. The multiple modes that the planes can be in confuse the pilots, and the stories that I've read carefully one after another are kind of frightening. That the heading of the plane is not shown in an apparent way. The state of the autopilot does not show that it's in landing mode 2 and then switches to aborting the landing. In one Airbus crash in Thailand, the plane decided it was going to abort and began to turn up. The pilot pushed the stick to go further down. The plane turned to go further up. The pilot pushed the stick to go down. The plane went further up, stalled, and everyone was killed. Okay? Completely unnecessary kind of outcome. If the engineers and designers had been more thoughtful about giving information and gave the status to the pilots, they might have avoided that. So the solution that I advocate is National Algorithmic Safety Board, and I just close by, and happy to have questions. To design for safety, the goal is to clarify responsibility. It's especially clear in clarifying responsibility for failures, and my approaches are independent oversight where there's open and adversarial reviews, transparency that opens the black box, accountability for open failure reporting and liability. So currently, many systems have hold harmless contracts, medical systems, for example, that in most software systems, the authors of those software tools do not accept responsibility. They say software is a difficult and unpredictable art, and if the software has a bug or goes wrong, we take no responsibility for it. That's kind of an adolescent approach, and I think it's time to move the computing field beyond its adolescent stage and for it to accept serious forms of responsibility. So I close with, you may have seen this television commercial, Hotel Trivago, this paired associate, Hotel Trivago. So what I want you to take away from this is safety, responsibility. Safety, responsibility. Safety, responsibility. Those are the ways I think we'll get it. If you want safety, which I think we all do, then you're going to have to address the fact of responsibility. And it troubles me that in many situations that is unresolved, especially the driverless car situation. Who pays for damages? And I think the early clarification of that will accelerate the movement towards driverless cars, which I see as a virtuous possibility. And I want to see it happen. I want to see it happen in a responsible and positive way. So there we are again. Safety, responsibility. Okay, thank you.
Thank you so much, Ben. So we have time for questions, and we can get started. We have people with microphones, so if you would just put your hand way up so they can see you. And gentleman in the yellow jacket there.
It seems that you assume that you can derive an explanation either by building a system that's going to have explanation built into it, or that you can do the forensics after the fact. But it seems that we're at a point in design based on large amounts of data where you will no longer be able to do the forensics. Why did the driverless car not interpret the bicycle walking across the street? And so I think there's a problem with the assumption that you'll be able to do the NTSB kind of analysis, and I think you're going to have to go to a direction where there's going to be a authority who will validate an algorithm, held out data, cross-validated and certified in some way, because I don't know how you'll do the forensics when there's a black box with 100,000 parameters in some machine learning system that says the answer was black.
I would say if it's that much out of control, if it's that poorly designed, shut it down. Okay? Now, I know the counter is, well, would you rather have a safe system or one that you have an explanation that's not as safe? I don't think that's the choice. I think the choice is to get a safe system which is explainable. I think the engineers are up to it. My optimism is guided by the FAT-ML conference, fair, accountable, and transparent machine learning. 4 years of pretty interesting work in that community. I'm encouraged by the DARPA XAI, Explainable AI program. I think what we need to point out is that the past history of some workers in AI have been driven by game-like applications, whether it's Go or chess or other kinds of things, or things that were not consequential. Okay, they're valuable, natural language translation, speech recognition, but when we move towards consequential things, I think we should have higher expectations from the engineers who built these systems. I think that's where we're going. If they want to be contributors to these important consequential applications, they've got to get their act together or shut them down.
And some sort of government certification that is driverless
Well,
car.
I was not too pushing hard about government. These days, a government certification. There is, I repeat, strong industry support. The Partnership for AI is the leading 5 top companies who are pushing for some form that will develop that would give them assurance they're doing the right thing. And I would say I don't buy this, and I get angry, excuse me, of the argument from some of the AI, 100,000 features, parameters, 100-level neural networks. How can I possibly explain it? If you can't have a way of saying, on the next time when I see the same data, I'm going to get it right, shut it down. I mean, I think that would be the test. If when something goes bad, and you've captured the log of what happened, fix the program, replay it, and show me that the same thing does not reoccur. Okay, I think that's the kind of test. Thank you. Okay.
Okay.
So, hi, I think my question is actually thematically similar to the previous question, but I mean, for your recommended interventions here for governance, you lean on different mental models of regulation and oversight, like monitoring and data sharing, like post hoc analysis and so on. I mean, do you think that the issue of algorithmic accountability can be regulated using these existing mental models for this kind of monitoring, or do we need new ones? In part because of phenomena like like complex interactions and like the difficulty with getting like input A, output B every single time in these systems. Like, do we need a mental model that like accommodates like fuzzier kinds of outputs, or a probabilistic reasoning, or something that looks at interaction effects, or something? Like.
I'm getting closer to what you want. I'm not sure exactly what you're meaning by mental models, but I think mental models are a useful way to describe it. My mental model in an elevator is I press the 7th floor and it gets me there. I don't understand all that's going on, but I trust that there's a reliable system that will get me there. I also see in the elevator that it has an inspection certificate, that someone's checked to see that this elevator functions as promised. I don't expect every consumer or citizen to be completely knowledgeable about it, but I think the mechanisms by which various intermediaries, consumer groups, public interest groups, and so on can act in that way. There's a role for Underwriters Laboratory, for Consumer Reports, for Better Business Bureau, all these traditional groups that helped accelerate commerce by building trust. We need to invoke them in new ways, maybe, and they will guide us, I think, to get the right idea. I think, again, some of the AI people say the only way to control AI is with more AI, and I don't agree. I think the only way to control AI is to have a social mechanism, a political mechanism by which there is an open discussion and which failures can be investigated openly. All right, thank you.
So over here?
Yes, thank you.
Thank you. So safety and responsibility through the shared logging, and then also better tools for the analyst,
yes.
Right? My question is related to especially thinking about autonomous vehicles. What is the model to incorporate kind of the community level knowledge that is needed? Because I'd imagine the driving behavior should be different in different parts of the world and like different neighborhoods. So what is the framework to incorporate community data in a way, like this kind of local knowledge that maybe doesn't come from the analyst or NTSB?
Yeah, I mean, this is discussed in the driverless community that maybe different cultures, different countries will actually have different forms of regulation, different values or ethics introduced there. I think the model for that would be the local planning boards. The local planning boards have some decision making. Now, you don't want to have automation at every local point, but maybe at the state level in the US, and again, maybe at industry level would be another way to partition the space. That I think you might have a planning or oversight board based on medical devices. And the experts in that field, which some of what FDA does already, would be the ones that you would invoke. Just as for the Transportation Safety Board, you have that for automobiles, ships, and trains. So I think there's examples to build in. And again, it's just to open, it was a challenge for me to open my mind and to think outside the technology solutions and to think about how you can create the right incentives that will build the right technology solutions. You see other hands? Yeah.
Oh, wait, we
yeah,
have a
yes.
question over here.
Thank you.
Yes, two questions are somewhat related. So first, a practical one, that you say there is a planning phase, but when do you envision this planning phase? Because you don't want to shut down innovation in a research setting. And so I was thinking, for example, for drug discovery, right, there is a clinical trial phase. Could there be some kind of testing phase
Absolutely.
that actually is based on evidence?
Absolutely. I hope I made clear. You know, research should proceed. You don't need to have a review document for research. And for many things, you should be able to. It's only when, Kathy O'Neill, when you're at scale, when you're going to field, if a major bank with 3,000 branches is going to install a new system for allocating loans, that's the moment. And those, they have planning documents. They plan to do that for whatever, a year or 2 years. And at some point during that process, just as they would if they were going to build a building, they would have to go for permission. And I think we should come to see the construction of major, scalable, and consequential tools that should have a review process, whatever, 6 months in advance of implementation, and then a review process before the button to launch it goes. And the development also, we didn't talk about the set of test cases that would verify or help validate. It was part of the USACM list. But there would be an agreement that these are the 27 or 2,700 test cases that we should run before your algorithm can go.
So a follow-up question during these test cases or the planning phase. So in the cases that you focus on safety, I see more clear that there could be a yes or no answer. But there are some parts of AI that are much more subtle. Maybe that's related to these mental models. But for example, if you apply an algorithm to help you guide how do you do education or something that the impact could be much farther. And I mean, there is not a safety, a risk, an immediate risk that you get from the algorithm, but there might be an impact in society over time.
Sure.
How do you evaluate those?
You're right. I mean, there will be subtle cases where you're saying the impact could be far off. You have an AI system that grades your homework, and you fail a course, and the consequences are quite far, but the algorithm was mistaken. Okay, and we had the recent case of the fMRI data. 40,000 papers, I think it was, were invalid because the algorithm in the fMRI system was incorrect. Okay, and those things happen. So we have actual bugs in systems, but we have poorly designed systems as well. And I think we need to develop the strategies to make that happen. Yeah.
The case for better controls on important systems certainly is a strong one, but I think we should see it as an opportunity and be more optimistic that the automated systems are more, not less, susceptible to the controls. What are the controls over unfettered human discretion in mortgages? What is the reconstruction mechanism for why a human driver had a crash?
Yes.
So I think it's a very positive kind of thing that as our systems are more and more knowledge-based, they're better able to be inspected. Human-based systems are not very inspectable.
That's a little harsh, I would say. You know, accidents are investigated where humans are part of, and loans at banks are monitored by the Federal Reserve. You don't believe that?
I don't believe it's
sure, it may be ineffective and may fail at times. So, you know, maybe we need to way to strengthen those. But I do think there's the need to integrate a higher level and not technical, that's beyond the developers. The developers say, trust me, it's going to be fine. Don't win the day with me, okay? If they want to present it to others and say, I've adhered to these 27 guidelines, and here's the system that's out there. We're going to have a pilot trial for 3 months. We'll validate it during that. You know, just as any new aircraft. New aircraft, there's a good example, gets certified by the FAA, okay? There's a testing process by which it's certified, and then they get a certificate that allows them to sell and have passengers travel on those planes. And I think we can find those mechanisms. They will be imperfect. I know that. Current human systems are imperfect. We're always striving to be better. I think that's also something, somehow the AI and often the tech community and computer science, my colleagues, assume the world can be made in a fully rational way and that everything can be algorithmic and that if we had only more rational discourse, that everything would be fine. But life is a little more complicated, I would like to say. And so I think we have to deal honestly with the complexities of real life. So.
Go right ahead. Did you have a question?
Another question?
Oh.
Okay. Oh, lots
right
of
here.
hands.
Okay.
Thank you.
Hi, good afternoon. Thank you for this good talk. So my questions maybe touch on a couple of things you just said. I'm curious about what your thoughts are on the culture of programming and where that might go. I mean, we're here at a teaching institution.
Yeah.
My own experience with programming is that the culture tends to be fairly Wild West.
Fairly what?
Wild West. In terms
Wild
of,
West.
In terms of
Okay.
standards. And also just, sort of how it goes.
Yes.
And part of that question there is really about how we deal with complexity and hyper-specialization. And then separate from that, maybe, as I'm wondering what your thoughts are around feedback loops. As these AI algorithms become more complex, the feedback loop into how society works becomes more profound, I think.
Yeah, those are rather larger things, I would say. The Wild West nature of the programming community has been faulted on many occasions, and I don't think I want to go too far with that, but I think Wild West is a safe enough one, but there are many problems. I think the culture of programming. I think courses in ethics in programming should be required. I think they're part of the required curriculum, but many universities don't include such a course. The ACM has a code of ethics currently being revised, and that's another good source to look at. So there are ways we could make, and as I say, it's an adolescent culture maybe is another way to say it, which I'm looking for it to seek maturity. And maturity means taking responsibility for what you do. And there may be things like those hold harmless clauses that I think could be changed. And that when companies take responsibility, I believe more good things will happen. Now your second point was the feedback loop. Yeah, I mean, yes, I'm not sure that's controversial, but
how do we know when the perspective, our perspective, how do we know when our perspective has shifted to a point?
Who's the our?
Societal perspective, right? So if we're looking at keeping track of algorithms and saying, well, this algorithm isn't behaving correctly, but that's our subjective opinion.
Yeah.
And that's subject to change, but it's also
all right,
subject
you
to
raise another issue which came up earlier in the day of the role that we might have as academics in creating public discourse and informativeness about this. And I think that's a valuable thing. I have sort of struggled with the battle of the rise of the robots. The robots are going to take our jobs away. There's going to be widespread unemployment. I think that's preposterous. I just think that's a failed understanding of the nature of technology. I see the effect of technologies producing what I call technogenesis. That is, new technologies generate a lot more than they destroy. Yes, Gutenberg's presses put the scribes out of work. You want to count how many unemployed scribes? Okay, we can count those. But it created a worldwide literacy, a readership, publishing industry, and most importantly, it amplified the potential for creativity of writing. Writing was not a common process. People did not write books. And every technology, whether photos, photography, 1839, Louis Daguerre makes photography. A French painter, Delaroche, says, from today, painting is dead. Well, I don't think he got that right. And photography opens up a world where now everybody has 100 selfies on their phone. And everybody's a photographer. You create a world of opportunity. Gramophones, music players, iPods, and your phones, okay? Did that wipe out the performance of music? No. Did it change it and challenge it? Yes. Okay? Are there more people? I really wonder, are there more people making music and composing music than there were 100 years ago? It's kind of an interesting question. I tried to find that number. If anyone could help me with that, I'd love to see it. But I would say that technologies which would seem to wipe out the jobs of a certain category create technogenesis. They generate huge industries. Similarly, I mean, I've got about 20 of these I've been writing down. I think you get the idea. I'll give you more if you want them. But
we have like 3 more questions, Ben.
Yeah.
We have 1, David, 3.
So
Maybe.
I wanted to ask, I love the talk about accountability of algorithms, but I ask about the partner of algorithms. So algorithms are pretty innocuous by themselves. It's the data that
That's right.
gets them into trouble.
Yeah.
So I'm wondering what you think about data accountability.
Yeah.
The data that forms the algorithms and the data that algorithms operate on.
Good. Thank you. Yeah, absolutely. I run into this because I'm a proponent of visualization tools. And I might say, again, take a look at Fernanda Viegas's work at Google on use of visualization to understand machine learning and neural networks. And it's a whole effort at Google that's been transformational. Another one of those that encouraged me to believe that you could have these kind of things. So the data, though, has a few problems. The one I run into most is the data is poor, the quality of the data. It's incomplete, it's contradictory. There's all kinds of things. I could tell you lots of stories where the visualization tools that we developed reveal problems. 6,300 emergency room admissions, and they're asking the average age of the men and the women and those discharged. And they had no idea, after running all kinds of stats, simple stats, not machine learning, but they had no idea that 8 of those patients were 999 years old. Kind of a simple thing to miss, isn't it? They had no idea that about 60 of those patients were under 1 year old. A very unusually large number. And that was because in part of the hospital, the way they entered the age of the patient was they entered the birth year. And they made consistent errors of entering the current year. So you get lots of patients under 1 year old who have heart attacks. Okay? This goes on and on of duplicated data. A year worth of sales data. They're making a predictive model to plan the next year. They had no idea that April was missing. All the spring sales of April were not in this data set. And so the data, for me, the first problem is the data quality, incompleteness, and so on. I could go on with stories. But the other part is the bias. And here I would say the technical progress has been the most strong. The FATML community, I think, has done a fair job of looking at what would be biasing data for a particular. So loan applications, since we have legal restrictions on bias for gender and age and race and so on, we know that there are certain, you don't want to have those fields in the data, and then proxies such as zip code may be a problem as well. And these will be specific to particular industries. And so I think that probably shows opportunities for fairness. There will always be emergent bias. Helen Nissenbaum and Batya Friedman long ago wrote a very thoughtful paper about the different kinds of bias. So that gives us a model about what to look for and how the context changes. What wasn't biased 3 years ago now is biased because of some change in the context. And that's what went wrong with the Google flu trends. Another dream of AI of predicting where flu outbreaks would be greatest in the US by the search queries that people searched on of flu or tissues or other things or medications. And it turned out that went so bad that Apple shut that down, and that website is gone. Google, I'm sorry, Google, thank you. Apple's, okay. So Google shut that down. There's a wonderful 3-page paper from 2013 in AAAS Science by David Lazer, is the first author, Lazer, who has a wonderful analysis of what went wrong. I think studying the things that have gone wrong with algorithms will help us a lot. Yeah, you said 2 more?
Yeah, David?
Yeah, so I wanted to start by thanking you for being here and for leading this discourse. I think you can tell from how animated everybody is that you've really engaged us, so thank you for that. And I also want to agree with you that I think the retrospective is the easiest one. I think that one, that makes complete sense to me. I do want to express some skepticism about the planning committee viewpoint, and then also, if I may make a quick comment about deep learning as well. I really resonate with the point that Mercedes made, which is that I think that, a different way to say it is that a planning commission for a building has a much easier task ahead of it than a planning commission for a computer technical system. The proximate concerns in regard to a building, I think, are perhaps easier to understand. You described it. Is the light of the building falling on my neighbor? Is the building environmentally appropriately built? Is the energy system safe? The proximate kind of potential side effects of an AI algorithmic system, especially as AI begins to kind of essentially do everything. I mean, it seems to me that your planning board would have to kind of form a viewpoint on what's right for society and what's not right for society. So wanted to make that comment and invite you to respond.
Yeah, let's stay with one piece at a time. Yeah.
Okay.
And I'm happy to engage. I know some people have to leave, so thank you. But, well, I don't know. I've looked at only a little bit of building codes, but they're pretty complicated. So I don't think it's as simple. We've had 100 years of experience in developing them, and so maybe they seem apparent. I don't think that it should be so impossible to build a set of codes or rules for the way AI systems should be built. And I think we're going to get there, and I think we should value and respect the AI researchers and engineering communities that they can do this. We just have to set the public expectation they should do this, okay? And you made one passing comment there, as AI systems get into everything. I don't know about that. I don't think AI systems are as prevalent as the hype suggests. When I do email, I'm not using much AI. A good design of systems and screens and websites are really what drive things. You begin to see AI, okay, recommender systems are there, and we have other machine translation, natural language translation. But I would say AI is a small part of the world. To me, the larger issue is the design of systems and of the user interface. So I think, we should be clear that AI is not so pervasive as is said, and we should be careful about what we call AI. There's a lot of language now where suddenly everything is AI. Every algorithm is an AI algorithm, and I don't see it that way, okay? So, I mean, we ought to get better about these clarifications. Okay.
Okay. I think there's a longer debate there, but we're definitely at an inflection point where AI will be doing more and more. And also, we're also in a situation where a lot of things that have been AI are no longer thought about as AI, so that goes in the other direction as well. Let me get to my second point. Let's posit a automated vehicle system that is using a black box, deep learning technology, and that through its deployment saves hundreds, maybe hundreds of thousands or more lives, and yet now and again it does something really, really stupid, and it kills somebody in a way that a human would never do. And again, this is a black box system. This is a deep net. This is a system that you said that you would shut it down. Would you shut that system down?
All right. So I'll give you an example. Let's see if we can. Airbags. The early deployments of airbags, is the airbag system deployment AI or not?
I've lost the microphone. I would say probably not.
Probably not. Okay. But it's an algorithm. That's why I chose to focus on algorithms, not only AI. Early airbag systems, the estimate was it saved about 2,500 lives a year. On the other hand, the early airbag systems killed about 100 kids, mostly in the passenger seat, a year, inadvertently, because the airbags were triggered and the explosive force of the airbag was such that it killed the child. Okay? that should have been avoidable. That should have been something that was taken into account. The engineers did not get it together to anticipate that problem. Now, okay, maybe I'm being harsh on them, but there was a fix. And so you have a fix that detects whether the passenger is seated, and you can control the airbag a little better. You can't control everything about the airbag, and because the rapid deployment in 200 milliseconds means it has to be an automated system, but I can control it so I feel safe about putting my child there, and I know that I put my child in a rear-facing seat. So we come to learn how to build those systems, and I think making the AI community aware of the dangers there will lead them a path where they'll be more responsible in taking care of it. And then the feedback that you asked for, I mean, good news that the Highway Transportation Safety Board was collecting the evidence about inadvertent airbag deployments that killed. If we didn't have that feedback, then we'd never get that fixed. And so this mindless approach that says, don't bother me, I'm just doing it, my system will be great, everything will be safe, doesn't work. And again, another positive thing, the airline safety record is exceptional, and I think that's due to the kind of feedback systems that are built in and responsible engineering.
All right,
We
Ben,
one more?
one last question, and I'm sorry to those of you who in the back who you can come talk to Ben afterwards.
Yeah.
Sorry.
Thanks for a great talk. The most widely used system that probably bears no responsibility is Google Maps. What changes would Google Maps need to make so that it avoids doing things like accidentally sending people into fires in Southern California, to cite one more recent example? So is it that it needs to be like, by the way, if you see a fire, don't keep driving, or does it need to, or what fundamental changes would need to make to
Well,
avoid?
let's go back here. I'm still resonating off of your question. Is Google Maps an AI system?
It certainly has AI.
It does? How so?
Because it takes a large amount of data.
Wait 1 second. Sorry.
Sorry. Well, to give you to cite that example, it sees how cars are moving in Southern California along the highways. It sees that it doesn't see any traffic along, say, the 5, and it says, oh, go take the 5. That'll get you home fastest. And then people get on the 5, and they realize there are no cars on the 5 because it turns out there's a big fire. That would be one example.
And that's AI?
I would argue that is AI.
How do you know when it's AI? You touched on this also. I mean, Google Maps, as it started, did not have AI. It was very good routing algorithms, and that's how it worked. Now, it's come along with some more refined points that it amazingly integrates current traffic data to give more refined judgments. But I'm not sure I would give it the notion it's AI. You alluded to the idea that once AI systems get mature, they don't call it AI anymore. Well, I would say I have another, maybe more cynical view. Maybe I'll risk it. Actually, they were trying AI methods, but the AI methods didn't work. And they cleaned them up and they did good engineering, and it was clear, comprehensible, and predictable, and then it worked. So it's no longer an AI system because it was no longer called an AI system because it's not an AI system.
Wow. Okay. And on that very uncontroversial note, let's just thank Ben again.
Thank you.